Hey there everybody, I just thought I'd do a quick video to show the method for doing the Taylor series library approximation of a square root, because the method wasn't quite clear in class. So the assignment, we were doing the square root of 11. Now the method we're going to be using is based on what we already know, the square root of a number times the square root of another number is the same as the square root of the product of those numbers, like so. But we're going to be working the other way. So, with the square root of 11, what we want to do is find the highest perfect square. In that case, we know 2 squared is 4, and 3 squared equals 9, and 9 is as close as we're going to get to 11. So, if we divide this by 9, we get the square root of 9 times the square root of 11 over 9. And now we can take the square root of 9, which that's 3, and we're at the square root of 11 over 9. Now this is an imperfect fraction, so we can divide that up into 2 pieces. So those 2 pieces are 9 over 9 and 2 over 9. And that's the square root of 1 plus 2 over 9. Now the Taylor series library tells us that 1 plus a small x to the power of alpha is approximately equal to 1 plus alpha x. We all know that square root can also be to the power of 1/2, so this is the same as 3 times 1 plus 2 over 9 to the power of 1/2. And that's the same form we're looking for. So, using the Taylor series approximation, then, we can have, keep our 3 there, this is going to be 1 plus 2 over 9 times 1/2. If we multiply this out, these 2's cancel. These cancel out. And we're left with 3 and 1 plus 1 over 9. So we multiply these through, and you have 3 plus 3 over 9, which is 3 plus 1/3. And that is 3.333 repeating, which is pretty close to the actual value, which is 3.316, and so on. So that's the basics of how that works. So the other question for the assignment, the other group for the assignments was the square root of 17. So we can use 4 squared, which equals 16. So we can have root of 16, and then the root of 17 over 16. And that's going to give us 4, and 16 over 16 plus 1 over 16 the power of 1/2. So you notice I skipped a couple steps this time. And that's what Kimber was doing. He was skipping steps and making it unclear, but now you have a recipe up here. So that's 4, 1 plus 1/32, which is 4 plus 4/32, and that's the same as an eighth, so 4 plus an eighth, which is 4.125. Okay, hope this helps.